7.1 is on the definition of the Laplace transform. So Laplace transform. So we're going to go over the definition. I'm going to try to go slow. I'm going to go really slow when I do these examples, so that you understand. So I'm going to go like really, really slow. So definition of the Laplace transform. See, I can move around and it doesn't follow me. I can do this. I can, it's just nice. I'm free. So here's the definition. Suppose that we have a function f, and we're going to define it on 0, infinity. So suppose f is defined on the set 0 to infinity, like this. Okay. The reason we include 0 and we don't include negative numbers is because we're going to think of things as functions of time. So f is going to be a function of t, and t will be time, so time can't be negative. Then this thing here, so I'm going to use a cursive L, okay? So cursive L, like this. You don't have to use a cursive L if you don't want to. It's totally up to you. You can, use a regular L. That's a cursive L. The Laplace transform of f of t. Those are set brackets, by the way. They're not parentheses and they're not regular brackets. It's like, how if you have a set like 1, 2, 3, like this, that's what I'm doing, okay? My teacher would do this when I took the class, and I thought it was new notation. He was just being lazy, so I just want to be really clear. So this is equal to the improper integral, so from 0 to infinity, of e to the negative st f of t dt. This is the Laplace transform of f, is the Laplace transform of f. Assuming it exists, so of f. Assuming like this integral converges. Remember, this is the limit, so if we get a number, if we evaluate this and we get a number, we say the interval converges. If we get infinity or d and e, we say it, what's the opposite of converging? Do you remember? Divergence, yeah. In this class, it'll always converge. However, on the fourth test, we'll be doing some convergence stuff. We'll be doing series in the fourth test. We get to review all series from Calc 2. Couple remarks.
Is it cursive S?
Oh, I am so sorry, Rafael. Yes, I forgot to mention that. That is a cursive S. Yeah, no, it doesn't. And the reason I do a cursive S is because that's right. Yep. The first time I taught this class, I'm like, okay, I can't handle the S. Like I had to change it to a cursive S. Yep, that's a cursive S. So the first remark is the E thing. That E. This has a name. This is called a kernel function. Kernel function. There are multiple kernels. Different kernels will give you a different transform. You will study transforms because most of you are going into some type of applied math or engineering type field, so you will see a lot more of this. I did mostly pure math, so I didn't see too much of this, right? Took 2 DE classes and I did mostly proof, pure math. So it's called the kernel function. 2. This is a really important remark. F of t, and this is an obvious statement. It is a function of t. So this is a function of t. Sometimes it's important to state obvious things. I mean, why not? So, right, because it's f of t. So t is usually time. Okay, t is time. The Laplace of f of t, so the Laplace is a transform. So it transforms the function. It transforms a function of time into a function of, and usually nobody knows, but I'll ask anyways. Does anyone know when we integrate this, when we integrate with respect to t, what variables will be left? S. The s. Very good, Sarani. Very good. So this is a function of s. So the Laplace transform takes a function of time and transforms it to a function of s. It's used for a bunch of stuff. Someone in my morning class said, what does the s mean? And they were asking if it meant like spatial dimension or something. It's like, I don't really know. S is a complex number a lot of times. Not in this class, but in engineering classes, S is a complex number. If you look up on Wikipedia, there's a gazillion applications for this. It's just a transform. I'll explain how we're going to use it in this class in a couple minutes. So it transforms a function of time into a function of s. 3, it will exist. It exists if, well, there's two conditions for the Laplace transform of a function to exist. The function has to be continuous, but actually we can demand the weaker condition. It just has to be piecewise continuous. So if it's a piecewise function, each piece has to be continuous. So exist if f is piecewise continuous. So piecewise continuous. And it has to be smaller than an exponential function, so and of exponential order, That means it has to be the same as an exponential function or smaller. So if you take the absolute value of the function, it has to be less than exponential functions. It can't be bigger than an exponential function. That's the condition for it to exist. And the fourth thing, and there's one more thing I'll mention after this, which is really cool. It's linear. So L is linear. Id est. That means that is, by the way. I.e., I think it's id est. It's Latin. You use it in math a lot instead of writing that is. So it's I period E. Have you all seen this before? The I.e. Is that what it means? Id est. Yeah, it's like that is. So instead of writing this, you can write that is. You do that a lot of math proofs because you say something, but then you want to say it a different way. So you'll say, so m is even. That is, m is equal to 2k. So you, instead of saying so or then, it's a nice transitionary phrase. Anyways, it's linear. What does that mean? If you think about integration, you can integrate each piece. If you have like x plus 2, you just integrate each piece. Same thing here. It's an integral. So L is linear. So you can do the Laplace of alpha times f of t plus beta times g of t. Oh, I'm running out of room here. Uh-oh. I'll make it work. Is equal to alpha Laplace of f of t. Was it this class that I was being made fun of for my...
Yes.
Was that this? That was this class?
For what? Writing in the middle of the keyboard?
My beta?
Oh, yeah. Can I show you real quick?
You want to come up here and show me? You don't care. You'll be on the thing. Oh, you can say hello. Come on. Oh, that'd be so good because I don't watch any of it. I just post it. I don't edit it. Like, too much to do. This is Raphael. He's awesome. That's it right there. Make like a comment now. That guy's cool. Like, no. No one wants the thing. That's good. Good. So basically, you just take the Laplace of each piece. That's what this is saying. It's alpha Laplace of f plus beta Laplace of g. Alpha Laplace of f plus beta Laplace of g. Like that? I don't know if I can go. Yeah. Oh, it's so weird. I don't know. It's too like, I don't know.
Can you explain 3 again?
So it exists if f is piecewise continuous. So that means that if you have a piecewise function, each piece has to be continuous. So continuous. And exponential order, since you asked, means that, I'll write it up here. So good question. Exponential order means if you take the absolute value of f of t, it's less than or equal to m e to the ct, and this is true for all t. And for constants, and for cm, and cm constants. I don't say something else actually. For all t bigger than, from some point on, it has to be smaller than an exponential function.
And that's based on the fact that the kernel function is e to the negative st, which is the same form.
Yes, and now we're going to talk more about that. Yes, I'm going to explain why. I'm going to try to give you the intuition, which I kind of made up. I don't know if it's true, but I think you might agree. So if you agree, then we're right. So here's my thinking on this. So I mean, this was made up for various reasons, and we'll talk about why it was made up in a minute. Oh, it's so cool. I can just walk. Look, I can walk, and it doesn't follow me. It doesn't know what I'm doing. So here's the idea. Why do we have that there? I mean, there's different transforms, but usually most of them that I know of have e's here. So here's the idea. If you just had, say f is positive, just to keep it simple. If you have this, I mean, we're going to have all kinds of stuff here. We're going to have stuff like t squared, t cubed, t to the 4th. So you might have something like this. So what does this represent? The what? The Area, yeah, so there's like an infinite area, right? So if this keeps going up, this is going to be infinity. It's going to diverge. So what you do is you multiply it by this function. I like to call it like a damping function. I don't know if that's the right terminology. It kind of kills it. If you think about if s is positive, e to the negative t, e to the negative st, that's a really bad picture. It looks like this. It's exponentially decreasing. It looks like this. It gets small really, really fast. So if you multiply something that just shrinks like crazy, multiply this by this, what happens is it kind of brings it back down to size. It kind of takes you like down here.
Just give it a Xanax, you know?
Yeah, 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 okay, yeah, or that. Yeah, give it a Xanax.
It's just like muted. It's just done.
Yeah, muted! Oh, I like that word, yes. It mutes it, it's muted. So it's like, it's going crazy, then you have this exponential thing, you multiply them and it brings it back down to size. So it creates convergence. Because otherwise, this won't make sense. Right, so without that e there, this thing is usually not going to make sense. Does that kind of make sense? Because that way it kind of gives you, that's my idea, my intuition for why they did this. What is this for? So the idea is we're going to have a dE. And it's going to be equal to some piecewise function. Well, we won't have that. In the super extra credit, you have this. Okay? So you have like a dE, and it's equal to some piecewise function. Because I guess in electrical engineering, electricity is either on, or what's the other choice? Off. It's on or off. So you have stuff like off, on, off. You have all kinds of weird stuff. So it turns out you can represent piecewise functions using something called the unit step function. And it's very easy to take the Laplace transform of the unit step function. So given a complicated graph, you can represent it with piecewise functions or other special functions from math. And then what you do is you take the Laplace transform of both sides of the dE, and it turns a differential equation into an algebraic equation. Then you solve using algebra, like partial fractions, and then you go back to the dE and you get the answer. So the Laplace transform takes differential equations and transforms them into algebraic equations. But it has other applications too. That's just one of them. So it's used a lot, like a lot. I had two friends, and I remember they were electrical engineers, and they were doing this like in their homework. And I thought, oh, that's so cool. Why am I not doing that? I'm studying math, and they're engineers. And it was their homework. So you'll see it. It's pretty cool. So let's go ahead and do an actual problem. You'll probably have two questions on your test where you do it this way, using the definition. So to make it worthwhile, I'll probably put two on there, like an easy and a medium one. Any questions on the idea behind the Laplace transform? Any questions? All right, so let's go ahead and do two problems where we actually compute maybe three problems where we compute the Laplace transform. I'm going to do homework problems if that's okay. I think homework might be better than me just making them up. These take a considerable amount of effort to do, so I want to make sure if I do one, it's a homework problem. Remind me if you want, I can show you how to get the answers to some of the homework using Wolfram Alpha. It's a lot of homework. There's 8 of them in the homework that you have to do this way. Number 1, there's a video for it, so I'm going to skip it. 2, there's not a video for it. It's a little bit harder. So let's do number 2. We'll start off that way. So number 2, we have a piecewise function. So f of t, and it's t if t is between 0 and 1. So it's t if this is true, and it's 1 if t is bigger than or equal to 1. That's a t. It's a really bad t. I'm sorry. So again, mainly we're going to be using Laplace transforms to solve dEs. But again, you'll use them in other classes. Someone told me that they use it in signal processing last semester. He's like, oh yeah. So I don't know what that is. So. Find Laplace of f of t. The fact we even covered in this class, I think says a lot. Like this is a class that's just some school, and we're doing it, and it's like the whole test. So it's kind of cool. So solution. So basically, I like to write it every time, the Laplace of f of t. I'm going to write a little bit small. Okay. So I like to always write the definition down. So it's the improper integral from 0 to infinity. So 0 to infinity of our kernel function, e to the negative st, then f of t dt. By the way, if you look up kernel on the internet, you're not going to get this definition. You'll get other definitions. There's other definitions of kernel. There's like a gazillion definitions for kernel. So, yeah, I was just going to say that. I was like, isn't that one of them has to do with popcorn? Yeah, like calculus has to do with teeth too. Like calculus, I think, is like the plaque in your teeth or something. So we're going from 0 to infinity. But here, it's two pieces. It's 0 to 1, and then 1, and then t bigger than 1. So from 0 to 1, f of t is equal to t. So this is going to be equal to 0 to 1. So we have e to the negative st. And instead of f of t, what has to go here in this case? T. Good. So t, and then we have the dt. So plus. So we just replaced f of t with little t. Because when t is between 0 and 1, t is between 0 and 1, f of t is t. Plus, and now t bigger than 1. So we have to go from 1, and it's just t bigger than 1. So what do you think has to go here? Infinity. Very good. So 1 to infinity, and then it's e to the negative st, and then t, and then what goes here? Just 1 dt. Yeah, very good. I'm gonna go really slow. I'll pause, let you catch up. It's a lot of notation. Some people say, oh, it's just Calc 2. Yeah, I don't know. That S really makes it harder. So that, and wait till you see the harder ones we do. You'll be like, whoa. One semester, I gave one of these questions to my Calc 2 class as an extra credit question. No one got it right. Yeah, well, I told them it was worth 15 points. If they got it perfect, no, take it or leave it. Like, and one guy like messed up the minus sign. I didn't give him any points. So. Yeah, he didn't need them. He had 100 on every test. Yeah, he's doing fine now. He works at a bank. Okay, so he's doing good. He works at an investment bank. Yeah, he's doing good. Oh, I haven't even thought about this. What type of integration? How do we integrate this? What do we use? What do you think? Tabular. Yeah, tabular. Yes. Or integration by parts. Yeah. No. So let's see the fourth. Integration by parts 4 times. No. Yeah. Let's use tabular. So let's tabulate it. It's a verb now. So I'll write it up here. The tabular piece. So this is the part we're going to differentiate. So t. Then you take the derivative. So you get 1. Take the derivative. So we get 0. And then we have to integrate e to the negative st. Okay, so I'm going to write that here. So e to the negative st. When you integrate e to the negative st, what do you divide by? What do you think? Negative s. Yeah, the constant. Yeah, because it's like if you had e to the 2x, you would divide by 2. So here your negative s is your number. Even though it's a variable, you treat it as a constant. So it's negative 1 over s, e to the negative st. If you don't like the cursive, you don't have to use it, okay? Sorry. I know it's kind of uncomfortable. Like, it's kind of hard, like if I write something and then you write something else. I know it's tough. I had a teacher that used to do this. And I couldn't tell which was which. It was really hard. I called the first one X and the second one Y. It was so bad. Huh?
5 and scribble.
Yeah, it was ridiculous. So this one here, it's going to be s squared. Yeah, s squared. So it'll be 1 over s squared e to the negative st. And then you have to write the symbols, right? Do you remember which one to start with? Is it plus or is it minus? Plus, yeah, good. So plus, minus, plus, and we draw arrows.
So you're integrating the right thing.
Yes.
Okay.
Mm-hmm.
Like, that's not derivative?
No, so differentiate this one, then integrate this one. Mm-hmm. Yeah, take your time. I'm gonna really trying to force myself to go slow because it's a lot. There's a lot going on here. Okay, so now we just follow the arrows. So it's this times this. So it'll be negative t over s e to the negative st. So negative t over s e to the negative st. And the next one's also negative 1 over s squared. Negative 1 over s squared e to the negative st. And then we're going from, I'm going to scoot this up here. We're going from 0 to 1. Right, going from 0 to 1. 0 to 1. Okay? So that's just this piece here. That's just this piece here. So it was this times this. That gave us this one. And then this times this. That gave us this one. And then we're going from 0 to 1. From 0 to 1. I don't know if you remember this. Whenever you have an infinity, you have to replace it with a b, or a letter, and you take the limit as b goes to infinity. So I'm going to go ahead and do that now. Plus limit. B goes to infinity. And I'm going to go ahead and integrate. So when you integrate this, you just divide by negative s. So it's just negative 1 over s, e to the negative st, and then we're going from 1 to b. It's a lot of notation. It takes a lot of getting used to. Take your time. Try to write it all down correctly when you're taking a test. Don't try to skip steps unless you really know what you're doing. It's always better to show what you can. So, yeah. You're allowed to skip steps, but if you mess up, it's more points, I guess, because then Any questions? Any questions on this one so far? Questions?
Plus 1 to 0, yeah?
Where? 0 to 1. 1 to b.
Okay.
You see it? Because b is going to infinity. Yep.
And that only covers from the negative 1s to the... Because I usually make a box around the...
You want to do it like this? You mean?
That's what I want.
You could do that. You could do that. You can do.
No, I'm not saying you should do it. I'm just saying
No, that's fine.
what did it cover. Cool.
Yeah, 1 to b. Yeah, this makes it more clear. All right, which one do we plug in first, the 1 or the 0? The 1. And where does it go, into the t or into the s? Into the t. Yeah, it goes into the t. Because there's two variables. It makes it harder. Even though it's just calc 2, it's still harder. So it's negative 1 over s. And then it's e to the negative s. Right, putting the 1s where the t's are. Then minus 1 over s squared e to the negative s. I feel like I'm going to mess up. I'm not going to mess up. E to the negative s. And then you subtract. And then you plug in 0. So I'm going to put parentheses here. Putting a 0 here, this whole thing will go away because there's a 0. So it's going to be 0 minus, and then putting a 0 here, we just get 1 over s squared. And that's it. Because e to the 0 is 1. And then plus limit. B goes to infinity. I'm going to go ahead and plug in the b here for the t. So it's negative 1 over s, e to the negative sb. And then we do minus, but it's already a minus, so it becomes plus. I'll use a bracket here just because if I mention it, it makes it look better. 1 over s, e to the negative s, because we plugged in a 1 for the t. We're going a 1 for the t. Wow. So we plug in a b, subtract, but it's already minus, so it's plus. Plug in the 1, 1. Plug in the b, plug in the b, plug in the 1. Wow, right, this is like number 2. Number 3 is insane. We'll have to skip it and come back to it. Any questions so far on this one? Almost there, almost there, almost there. I know, there's one problem, right? And I'm really trying to go slow. I can do this really quick, then it's like, what's going on? Like, what? It's like, then I'll mess up. And I usually don't mess up after the second test. I stop making mistakes. So that's why it's triple points for every mistake, because it's not going to happen. So let's keep this. Oh, look at this. It's going to be plus. Or it's going to be plus because it's negative and negative, so it's plus. All right, so there's something that is really important that's going to happen here. Yeah, and this limit here is going to be 0. I'm going to explain why in a minute. I'll come back to that. And this is going to hang out. Okay, so kept this, distribute this. This is 0. I'll explain why, and this is this. Let's go ahead and talk a little bit about this because this is really important for the test. So you kind of have to, you're supposed to at least specify when this is 0. So when you're working out this piece here, the way to think about it is as follows. Bring the e and take it down like this. Just take it downstairs. Okay. And then you say, okay, b is getting really, really, really big. So it'll be 1 over something that's getting big, so it'll eventually get really close to 0. Sure, that's fine. But there's something that's missing here. S is a variable. So what is S? Well, you want to keep e downstairs. The only way that's going to happen is if SB stays positive. Well, B is already positive, so that means you need S to be positive. So for this to be true, this is only true if S is positive. So it's important to specify that in the problem. Super key. We'll do one later where it's not 0. We'll do it right after this maybe. So in the problems where you use the definition, it would be nice in the test, please do it, if you can add this extra condition at the end. If you don't, it's like -2 or 3 out of a 20-point question. So it's not the end of the world. Don't worry about it on the other problems, just on these, because you can see where it comes from in these problems, and that's kind of key. Things should always be 0. You should never get infinity in one of these or something. You'll know you're doing it wrong if these don't go away. Like yeah, you did it wrong. So does anything cancel or?
Yeah, the first month.
Ooh, yes. Yes, that doesn't always happen, by the way, but this time it did. Last semester on their test, they had like 5 terms and none of them canceled. They were like, oh, and it was right. So we have this. I want to write that first, but I won't. I will. It's college. I'm going to do it. It's DE. It's hardcore. And you can combine them, but I won't. And then S is greater than 0. And that is our first Laplace transform. The long way. Yep.
So on S, if you bring S underneath, it has to be positive. Is that what's going on?
Here, yeah. This here? Yeah, so basically you want this limit to be 0. So if it was just this, Urash, then it's 0. Because b is positive, and b is approaching infinity, so this is getting really big. But we have an S, so you want S to be positive also. Because positive times positive is positive. Because if S is negative, it goes back upstairs.
Yeah. If it's a smaller number, it gets bigger.
Right. Yeah, if it was like -2, it would go upstairs and it would just be infinity. Yeah. It's deep. This is the long way of doing it. This is comparable to when you're in Calc 1 and you find the derivative using the definition, or when you're in Calc 1 and you do the limits with the delta x and the c sub i's. Remember that a long time ago? Yeah. So it's comparable to the long way of doing things, except it's a lot longer. So a lot longer. So this was number 2.
So for the answer, do we always have to include S has to be greater than 0?
Yeah, or whatever number you get. It might be a different number. Yeah, we'll do one next where there's a different number. Only on the ones, by the way, the directions here will say using the definition. So I'll specify this. The nice thing about this exam is that you'll have the same 4 questions as the old exam. So it's the same format. So if you go over that old test, you're super ready. Like, you don't need to do anything else. I mean, you just be really ready. So it's good. One down. That didn't take too long. Oh, you must have. What time? Oh, yeah, it did. What time does the class start? 6:30 or 6?
Well, we started at 6:30.
Oh, because the lady, that was here.
And again.
Yeah, like 15 minutes. Yeah, we started like 6:15, right? Yeah, 6:20. Oh, I showed you a bunch of stuff. Talking about stuff. Yeah, I gotta stop talking. Okay, any questions? Let's keep going. Anyone like this besides me? I kind of like these. Anyone a little bit? Well, it's not bad, right? It's not bad. Be careful on the test. Just take your time. I'll try to put 2 of them on there, so that way you have like some. We should skip 3 for now. I think maybe. Let's do. We could do 4, but I'll do 4 in a minute. Let's do. Yeah, there's one with a graph. We'll do that one soon. Let's do. I guess we can do number 7. Let's do number 7. Yeah, let's do number 7. Number 7 might be a good one because it'll help us solidify this concept here. So, yeah, we probably need to do a couple more. So number 7. Number 7. I feel really bad I didn't print the formula sheet. Maybe if this takes us like super long and we take a break, I'll go print the formula sheets and come back and hand them out. That'd be really nice. It's only 1 page, so. So number 7 is f of t equals, this is a really good test question. These are all really good test questions so far. f of t equals t e to the 4t. You can do this in 10 seconds once you know some other stuff. So again, we're doing it the long way. We're doing it the long way. Later on today, I'll show you how to do this in 10 seconds. So find the Laplace. So find the Laplace of f of t using the definition. So using the definition. So that would be the directions. Because you wouldn't want to do it this way if it doesn't say to do it this way. Every once in a while, someone will take the exam and they'll start to do, it's very rare, we'll start to do every question with the definition. It happened one semester, and the guy came up and asked me a question, and I said, what are you doing? And he's like, what do you mean? I'm like, you're doing every question. He had done like 8 of these. I was like, no. Like, so he went back, and I gave him a new test, and he got an A, but it's just horrible. Like, oh my God. It's just like, no. Poor guy. It was just ridiculous. So, let's do it. So, solution. So we'll start by writing the formula. So Laplace of f of t is equal to the improper integral from 0 to infinity of e to the negative st f of t dt. It's kind of nice we have 3 days before this next test. That's kind of cool. I think it's because of the extra credit. I wanted to have time to talk about that because it's good for learning. Like, it's good to know it. I mean, it's extra credit, but it's not really about the extra credit. I mean, I guess it is, but yeah, it's about learning. This is equal to 0 to infinity e to the negative st. So now we just replace f of t with what it is. There's no piecewise one here. It's just a straight up problem. So it's t e to the 4t. So t e to the 4t dt.
Can you combine the exponents for the...
Good. Now we're going to combine the exponents. Good. Emily. Good. Let's combine the exponents. So the way I'm going to do it up here because I'm going to do it in a way that might seem counterintuitive. So you can add them. So you would get this. And then it's beneficial if you pull out a negative t and write it as s minus 4. Yeah, s minus 4. If you want, you can write it like this. E to the negative s minus 4 t. That might be better. So it might be a beneficial way to write it like that. That's probably the best way to write it. You might say, why? Why are you writing it like that? Why did you pull out a negative t? It's so weird. You might be wondering, why didn't I just do this? This is a more intuitive. If you didn't know how to do this problem, like if you've never done this, you might say, oh, that's easier. That's much easier to understand than this. This is key. This will help us at the end. It'll help us when we're doing that confusing step where you have to like figure out what s is. Everyone see what we did with the addition of the exponents? It's really sneaky. So in my morning class, I asked, what's easier? And then someone said this way. And we did this way, but it ended up being harder at the end. So I'm like, oh, don't want to go there again. OK, so this is equal to 0 to infinity. So I'm going to use this one. E to the negative s minus 4 t dt. Points? What? No, I didn't mess up. No.
I just didn't know what you were going to write. I was like, wait, yeah.
Yeah, I know. So many t's. It's like t. Good stuff. Yeah, the reason is when you bring this down, it becomes positive. It's easy to bring down. It's easy to see. So later on, we're going to have to bring that down. What integration technique could we possibly use in this problem? Tabular. Yeah, it's like every time. Come on, that was a really good observation when we were looking at that old test. Like you were like tabular every time. I'm like, yeah. Like wow. Like you looked. Like I didn't even notice. I was looking at it, but I wasn't really looking. So good, Kamal. Good. Okay, tabular. Let's tabulate this. So I'll do it over here. So we have t1, 0. Writing that down. Just differentiating the t. And then we have to integrate this monster. So it's not a monster.
It is a monster.
Is it? It's a little monster. It's like, isn't that a movie? A Disney movie? Little Monsters or something? I don't know, it doesn't matter. It's 1 over Gremlins. Da, 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 da. It's a great movie. It's one of those feel-good 80s movies with monsters in them. So divide by that, and then when you divide again, it becomes positive. Squared, yeah. Wow. Yeah, that's crazy. It's fun. I love the cursive, the cursive S's and the cursive L's. It's really beautiful. I used to know cursive. Now I only know how to write my name. Anyone still know cursive in here? Yeah. Wow. Wow. I had a teacher who would write in cursive, and he would write all of his tests in cursive and scan them and give us the test. It was such a hard class.
Oh, wow.
Yeah.
Actually.
Yeah, he was really old. He was really hard.
What class was it?
Advanced Calculus 1. He was cool, but he would stand right in front of the board. So he'd stand right in front of the board like this and talk for like 5 minutes and then move. And he'd say, and then x is equal to 2. But like, what? Like, it was just really hard.
Do you do that?
I do that? Do I really?
Yeah.
I'm not that bad, though. Do I?
Just in this one seat,
I think it's
like,
your ankle.
This is the worst seat to possibly sit in because you're covering everything.
Because you're right-handed, so you're always on the left side of the...
I'm going to stay here.
I've got a camera
It doesn't
in my
help.
leg.
Huh?
Like right when you're in the middle of the board, I'm like, there's this.
Oh, yeah, yeah. Yeah. I know. Where's the best seat in the house? In the Urash? No.
Probably be like,
Yeah. You? Can you see okay? Yeah. A little bit. Yeah. Okay, all right. So plus. Line is plus. Draw the arrows. Okay, yeah. Draw the arrow. Now I'm aware of it. Thanks. Okay, so this is Laplace.
Sorry.
It's okay. F of t. If I was taller, it'd be better. I had a teacher who used to have really long arms.
it's about surface area, man.
I was gonna say, wait, if you got taller, you could just block more.
Yeah.
Well, he was really thin. He was like a stick. He was like skeleton. He was like, with long arms. Like, and then x of t. Like, he was just like really like a giant. So it's just following the arrows. So it'll be this times this. So negative t over s minus 4 e to the negative s minus 4 t. That's just the first piece. Okay, that's just the first piece. And then this one's minus 1 over s minus 4 squared e to the negative.
Why is there a negative on that first one?
Hold on, let me see.
At the bottom.
It's on the bottom.
Yeah, it is.
Can you see okay when I write like this? I was just wondering. Okay, because I'm writing like this on purpose now. That's good. I can see it far. Oh! And then you do this. And I'm going from 0 to infinity. So, any questions? Any questions on this one so far? So please never plug in infinity. Don't do that. That's pretty bad. It's more than a -1. It's minus a couple points. I know some people do it. That's fine. People can do what they want to do, but
The text...
not on the test, right? It's a math class. Not supposed to plug in infinity. So I know a lot of physics people do it. I've seen people do it. I don't judge, but please don't do it on the test. Okay, so put a B here. Put a B here. And let's go ahead and put a limit here. I'm going to show the extra step. So limit B goes to infinity. Negative t. I'm just copying and pasting. I can't write any faster. E to the negative s minus 4t. And we're going from 0 to b. So I just did the same thing, and I added an extra bracket. Because Raphael had to mention it. I thought that's kind of nice. So I'll let you write it down. So I did show an extra step here. Again, I know it's a lot of writing, but you're able to take your time on the exams, so why not? Plus, whenever you're feeling like lazy on the test, just tell yourself, this is the only time in your life you're taking exam 3 and DE. Yep.
I just like draw an arrow. Draw like an arrow. That's supposed to be just have the things.
What do you mean?
Like just
Let me see, I'll come look. See, it doesn't follow me, so now I can move. Bye. Let me see.
like that. Okay. No.
Yeah, okay. I'll let that go. Yeah, that's fine. But if you mess up, yeah, all right, that's fine. That's fine. That's fine.
What's that? Just don't mess up.
Yeah, yeah. You know what he did? He just drew an arrow. He just like drew an arrow. That's fine. Yeah, I'm good with that. Your handwriting is really good, by the way, Mamoudou. I'm impressed.
First person to say that.
Really? I like your work. It's good. All right, so this is equal to the limit. B goes to infinity. I'm used to it, though. I'm used to grading your work. So yeah, maybe it's biased. Which one do we plug in first, the B or the 0? The B. And where does it go, in the T or the S? In the T. Yeah, good. It goes in the T. This is where it gets a little bit crazy. Okay, I'm going to end up coming to the other board as well. So I'm definitely going to use a bracket here. I really like Rafael's idea. So it's negative B over S minus 4. And then it's e to the negative s minus 4b. Okay. And then minus 1 over s minus 4 squared. And then it's e to the negative s minus 4b. Minus parentheses. You're saying, why are you putting parentheses? Because I'm going to plug in 0 now. The good news is, when you plug in 0 here, it goes away. So it's 0. And then it's minus 1 over, e to the 0 is 1. So we're just left with this. Okay, we're just left with this. So it's, I can't believe I haven't messed up. It's a miracle. Whew. Yeah, so we're here. I'm going to come up here. Any questions so far on this one? We're almost done. We're almost done with this one. Almost done. So let's talk about this. We know these are going to be zeros. Okay, so I'll justify them later. So this is 0 minus 0. We'll come back to it. And this is plus 1 over s minus 4 squared. And that is the answer. That's correct. How did I do that? Because I just checked it. How? I'll show you later. You can just look at it, and you can do it in your head. Yeah, I was just doing it again. That's why I stuttered. So let me explain the answer. Explain how to get the s. So how do we take this limit? Let me show you. So let's just focus on this one here. So when you're doing this, you keep the first piece. And then this one, you do the same thing we did last time. Yeah, bring it down. Good, Renee. Bring it down. Totally. Awesome. Yeah, bring it down. So it's e to the s minus 4b. So we want this to be 0. So b is positive. So what else needs to be positive in this case? S minus 4. Right, because you want that to be positive also. Because positive times positive is positive. So that means s is bigger than 4. So that's what you should include at the end of your answer when you're doing these. So it comes from this. By the way, this is b over an exponential. Exponentials grow faster than polynomials, so this will always be 0. So, right, whenever you have an exponential on the bottom, it grows faster than a b, so it's 0. You can use L'Hopital's rule, but please don't. Just write the answer down. It's good. Sometimes you'll have a b squared here or something. You know, you don't want to have to do L'Hopital's twice. Yep.
So when s is smaller than 4, they just diverges?
Yeah. Yeah, I guess so, right? Or equal to 4. Equal to 4 won't make any sense. Yeah, if s is less than 4, or less than or equal to 4, game over. Yep. Interesting, right? Yeah, so that's a condition. And later on, we won't be specifying this. I only want you to do it on these because you can actually see where it comes from in these. But in the easier problems, which we'll be doing later, which are awesome, like with the formula sheet, just write the answer down. It's good. It's just on these. Any questions on any of the steps on this one? Everyone okay with why it's 0? The b and the e? All right. Let's do another one then. Maybe we should do one with the graph, because someone mentioned that. 4 is pretty easy, so maybe we should do 5. 5 is a little bit harder. So let's try that one. Let's do number 5 from the homework. Yeah. Are you still writing? Oh, yeah, I'll wait. Yeah, sure. Yeah. Yeah, I'll wait. Yeah, we got time. Talk about Corona. No, I'm kidding. Yeah. There's 8 of these. It's a lot, right? And there's a worksheet that has extra problems. Number 1 is these. I wouldn't recommend doing it unless like you really feel you need it. But number 2 on the worksheet we'll do in class together. Yeah, there's 8 of these. A lot of these you can put into, like you can put this one into Wolfram Alpha. You type in Laplace transform and then, Hey, more people. Are you sure? Okay. Any questions? Any questions on this one? Don't worry, Lori. We're gonna do another example. So in theory, you should be fine. We're nothing new. We're doing the same thing again. All right, let's do it. Let's do another problem. Let's do the one with the graph. So I believe the one I wanted to do was number 5 from the homework. So let me erase this. So we'll do number 5 from the homework. So number 5. 5's kind of tough because they give you a picture and sometimes people, they don't know what to do. I think it's kind of cool. Like if you have like some graph, you can like basically find the Laplace transform of the function that defines the graph. So this is 1 and this is 1 and it looks like this. So that's the graph, the dark piece. That's f of t. And the question is to find the Laplace transform of f of t. So f of t is given by that graph. We don't even have to find f of t. We can just like go through it and find the Laplace. Well, I guess we do have to find f of t, but we can just look at it from the graph. So how do you do this? I guess the way I think about it, maybe it's not the way everyone thinks about it, is that if you have negative t, it looks like this. It's like y equals negative x. So this, you're just going up by 1. So this would be negative t plus 1, because 1 higher. It's like you're taking negative t and you're going up. So this graph here, this piece here, is negative t plus 1. Okay, so this line here is negative t plus 1. Because negative t is just this. So if you go up 1, it's negative t plus 1. And then this one here is just 0. So let's go ahead and do it. Laplace f of t. We know it's the improper integral from 0 to infinity of e to the negative st f of t dt. And notice I didn't write down the piecewise function. Sometimes I do, but I thought, you know, we can do it without having to write it down. We can just use the picture. So from 0 to 1, it's going to be this graph. So from 0 to 1, it's e to the negative st, and then it's just this piece. So it would be negative t plus 1. So negative t plus 1 dt. Good. It's kind of fun doing it. I usually, every time I do this problem in class, I always write down f of t as a piecewise function, which you don't have to do, because you can just get it from the graph. Oh, something interesting happens here. Then we're going from 1 to, what would go here, you think? Infinity. 1 to infinity, right? It goes on forever. And it would be e to the negative st. And what would f of t be here in this case? Just 0. Yeah, 0. We're going to talk about this. We're going to actually go through all of the work here just so you see it once in your life. It's never in the book. Like, they never show you how to. This is equal to 0, but they never tell you why. So I'll show you why.
Why do you pick 0?
Because that's the graph, 0. 0 is a horizontal line. The graph of f of t equals 0 is that. So this piece is 0.
Why is the other one negative t plus 1?
Because negative t,
Oh, it's just the equation of y.
yeah, but it's up 1. Because negative t, I have it memorized, like y equals negative t. So negative t plus 1.
Yeah. It's going down and it starts going up.
Yep, no, worth it. No, it's good, it's good, good, it's good. It's good to ask. It's good. I mean, what's your major again? What is?
Computer engineering.
Oh, okay, so you might see this, I don't know. Like, yeah. I mean, don't computer engineers make, like, circuits and stuff?
Yeah.
Like the little microchips? They could, right? So they use, that's what electrical engineers do too, right? I mean, they'd have to know, like some, so it's good. You'll probably see it. You'll probably see this again. Yeah. Okay, beautiful stuff. What technique should we use for this one? What do you think? Tabular, yeah. What else do we always use? Yeah, tabular. So let's use tabular on this piece here. I'll do it up here. So we have negative t plus 1. That's the piece we're going to differentiate. Okay, negative t plus 1. So we differentiate it, we get negative 1. Differentiate again, we get 0.
Why negative?
The derivative of t is, yeah. No, it's good. Ask. And then we have to integrate this one. Okay, so it'd be e to the negative st. What's this thing? Uh-oh, now shorter people won't be able to get it, so it's kind of bad. Okay, and then divide by, yeah, there's a story behind that. Negative 1 over s. I heard one time there was someone who did that on purpose, and like the other teacher was short and she couldn't reach it. It's so evil. It's bad, right? I mean, I can reach it barely. I'm 5'9", which is barely average.
Wouldn't have thought of that
I know, I always think about that.
behind you, like, or the, like, related in the morning, I guess.
Yeah, yeah.
So we also do the plus minus.
Good, and then we also do the plus minus plus. Good, Priscilla, plus minus plus. Very good. Yep. No, I wasn't done. No, it's not extra. I didn't mess up. I'll give it. Hey, I'm okay. I will totally give you the points, right? So, but I won't mess up again. It doesn't happen. I'm sorry. Huh? It's good. It's all right, Nick. We'll see. All right, let's do this. So let's follow the arrows. So Laplace f of t is equal to, so this whole thing is being multiplied by negative 1. So I'm going to put the negative on the outside, so like this. Negative, parentheses, negative t plus 1 over s e to the negative st. I wish I was ambidextrous. That'd be really cool. I'd have like 2 markers. You're ambidextrous? Oh. I can try. Let's see. So this will be negative and negative is what? Positive.
Oh my goodness.
What? What? No, it's like I'm 2. I know. It's like I'm learning to write. No. And then it's going to be 1. 1 over s squared e to the negative st. Yeah, it's 1 because they're both negative. Right, they're both negative. And we're going from 0 to 1. I'm going to use a double bracket.
So isn't it 0 to 1 and 1 to infinity?
Yeah. So now we're going to do this one. I'm just going to put 0 here. And I'm going to explain it on the side. Yeah, let's do this one now.
That was just the first part. Okay.
Yeah, this was just the first one. Now this one's going to be equal to 0, but I'll explain why up here. So that was just the first part. That was just the first part. I'll wait. I see people writing. I'll wait. It's a lot to write. There's limits, there's integrals, there's infinities, there's limits. I mean, it's just limits of integration. It's just a lot. It's a lot of notation. Yeah. So why is this 0? So basically, when you multiply this, you get you get 0 here. But let's go through it formally. What do you get when you integrate the number 0? A constant. Very good, Anna. Is it Anna or is it Anna? Okay, it doesn't matter. Anna. So this is equal to c from 1 to infinity. So this is equal to the limit as b approaches infinity of c from 1 to b. That's right. So you'd say it's the limit as b goes to infinity. Well, no, not necessarily. So if you plug in b, you get c. You subtract, you plug in 1, you get c. c minus c is 0, so this is the limit as b goes to infinity of 0, and that's just equal to 0. So whenever you integrate 0, and it's a definite integral, you always get 0. So the Laplace transform of 0, like if I put a 0 here, it ends up becoming the Laplace transform of 0. So the Laplace of 0 is 0. Kind of random. I feel it's good to go through it just so you see it. Because sometimes people just assume it's 0, but they don't know why. So now you know. Every time you see that, it's a happy day because it's gone. Right? It goes away. It's worth it. Oh, this is awesome. Look at this. When you plug in the 1 here for the t, we get negative 1 plus 1. So this is 0. So this whole thing goes away. So this is gone. So this is going to be 0. And then we're plugging in 1 here for the t. So it's plus 1 over s squared e to the negative s. Yeah, e to the negative s. So that's the t. And then minus, and then parentheses. Don't want to mess up here. So now we're plugging in 0. So this is going to go away, this t here. So it's going to give us negative 1 over s, e to the 0. E to the 0 is 1, so I think that's just going to be negative 1 over s. Yep, because it's gone. So you just get negative 1 over s. And then e to the 0 is 1 plus 1 over s squared. Notice there was nothing with the s, like s bigger than 4, s bigger than 0. Didn't come up in this problem. Didn't come up. That says distribute the minus. So we get 1 over s squared e to the negative s plus 1 over s minus 1 over s squared. And there's no condition on s that arose from the problem, so don't worry about writing one.
Needs to be greater than 0.
S needs to be, where does it come from though? I mean, it probably does, but where is it?
Well, in your final solution, them being.
It can't be 0, yeah. Yeah.
Because it's in there.
Yeah. Yeah, right, so, but yes, you could put that, but I won't like require it, because like it doesn't come from the limit. Yeah, but yeah, it definitely can't be 0, sure. Yeah, so you can make it greater than 0, but like it didn't come from like, you know what I mean, from the like, yeah, so don't worry about it. Yeah. Also, on some of the other ones, you'll see it too. The ones where you don't do the definition, don't worry about it. You only have to write it if like you get it from like a limit. So yeah, good question. Thank you. Good comment. So, any questions on this one? This one seemed a little bit easier, I think.
How do you get 0 when you
For this?
No. When you plug 1.
Good question. So right here, look, you get negative 1 plus 1. You see it? No, it's worth it. It's worth.
You were distribute, but they don't equals 1.
Oh, yeah, if you distribute, it'd be t minus 1. I never thought that's a good way to think about it. Good. I like that. It's good. It's good. Lori, does it make sense? Because you were a little bit late, kind of. So this is the formula, Lori. Basically, you always use this formula. So this is like, and so whenever it says using the, we're going to do another one after this, one more. When it says using the definition, you just always do this, and then, yeah, and I think you're right, Rafael. Well, we're just going to do one section today, because, yeah, it's pretty intense. Yeah, we have the easy stuff. I'm going to do a really hard one now, and then.
Aren't you missing the value of s?
No, don't worry about it. As Emily said, it's in the homework. They do this, but like you can't really get it from any of the like limits, so don't worry about it.
Okay. Do I have to worry about it?
No, not on this one. Only like when you have like like the limit with the b and stuff like that. Like when you take a limit, like like the last one we had. So
that one doesn't matter because it's already.
yeah. So you can't really see it from the work. So. Wow, it's already been an hour. Wow, it's already 7:28. How many? We've done what? 3 problems? No, 3?
3 problems.
3. All right, the next one's really hard. So any questions? And I feel like I have to do it because I mean you probably know how to do it, but I should probably do it. All right, let's do it. It's number 3. Number 3. Number 3 from the homework is the hardest homework problem. Number 3.
Remember how the last was the Calc 3 class when you made us do the number 6?
Oh no.
Oh, number 6?
You guys got it. You guys.
I've worked it out. It's in my notes. I've put it on test before. But usually when I put it on a test, that problem, I do it in class. So on the day I was going over it, hey, what's going on? On the day I was going over it, I saw it and I thought, I'm not going to put it on their test. And I'm like, yeah. I purposely didn't. I knew. Yeah, I checked the test and yeah.
So don't do this when you're doing stuff.
Oh, I don't know. Maybe you'll like this one, Udash. Maybe this will be like, oh, this is why I love math. And I'm going to change my major. I'm going to be a math major. And I'm going to start reading math books on weekends. And like, I'm going to change my life. You can do math like under a tree. Like, You don't need a computer. You just need your mind and a book.
You just take a laptop.
Yeah. You can disconnect yourself though, right? Like
You don't even need a book.
you don't even need a book. That's right. It's like natural.
Dream about
Laying in the grass with with a little notebook and a pencil. Dreaming in Spanish.
Dreaming is awesome.
You got a dream about the math.
I've had math dreams. They're pretty rough. I've never had a good math dream. Yeah, they've always been like confusion. All right, so fine. I'm going to write smaller on this one, sorry. I'm going to go really slow on this one also. I think I've been going slow. I feel like I've been going really slow. Trying. Let me try harder. This problem is ridiculous. Let's do it. Solution.
At least you know it's ridiculous.
Oh, absolutely. Every semester I think, I don't want to do it, but I have to do it. So this is going to be Laplace of f of t. And this is equal to the improper integral from 0 to infinity of e to the negative st. Do you remember what that was called? A something function, do you remember? Kernel function. Yeah, it's a fancy name. Oh, I just realized something. F of t dt. Wow, I just realized something. Oh. I've seen this before in other places, kernel functions. I thought I hadn't seen it before, and I remember it from somewhere now. So that's it. That's a fleeting thought. It's gone. But I know. Yeah, I did research for a little while, and we had kernel functions. And I remember the guy I worked with would say, "Oh yeah, it's the kernel function." I was like, "What is he talking?" Now I know. Like it just clicked. So I know. Yeah. So we're going from 0 to pi. So it'll be 0 to pi. And this is going to be e to the negative st. Here's our evil friend, cosine t dt. Okay? Plus, then we're going from pi to infinity. Very good. Very good. Pi to infinity. E to the negative st times 0. And that's going to be 0. Very good. See, it's good to see that you start to pick it up. Yeah. And once you do a couple of these, you're ready for the test, and you're 25% done. Remember, there's only 4 questions on your test. This is one of them, so it's kind of nice. Awesome. There's a phone in here. Someone called it once, in that room over there. And it was a collect call from jail, and I picked it up, and I accepted the charges. Yeah. Yeah, it's really bad. I shouldn't have said that on camera. Well, it was during a review, and the guy's like, "Hey, is Crystal there?" And I was like, "Is there a Crystal in here?" And I said, "No, sorry," and I hung up, and I felt bad. Like, that was it. Like, I ended his phone call. So this is 0. I was thinking, like, maybe he was like, huh?
SSC's like, that's why we got charged for a call.
Yeah, from Seminole County Jail. I thought, like, maybe he was a student in the class, and, like, he was missing the review, and but I was thinking, like, no, I know. If you're in jail, that's probably the last thing you're thinking about. Okay, so the Laplace, like, probably not thinking about the calculus review. Probably like, I need to get out of here. Like, like this sucks. Like, yeah, you have 1 phone call. I heard it's not true. I heard they get more than 1, but I don't know.
What if they don't pick up?
I know. It was a really weird experience.
That's how it is in movies. I don't know.
Yeah.
Must be true.
Must be true. I had a student who was a security guard at a prison guard at a jail. She said it wasn't true, but I don't know. So this integral here, is, will anyone know how to do it? Yeah, 2 times, right? Yeah, I call it a looper. I made up the name. You use parts twice. So many of you may have never seen this integral, or maybe you don't remember. So it's a definite integral. So what I like to do is I like to do the indefinite one first, and then go back and plug in the limits at the end. So we're going to use parts twice on this one. So I'm just going to do this just to separate our train of thought. So I'm going to call the indefinite one I. So I'll set I equal to the indefinite integral of e to the negative st cosine t dt. And we're going to go through the work and do it. This is a good integral. I mean, in theory,
Are you proper tabular or
parts.
straight?
Straight parts, yeah. So I'm going to write the integration by parts formula up here as a refresher. So if you have the integral of u dv,
Forget everything.
huh?
I forget everything.
I know. I don't blame you, Rafael. We don't use it that much. We always avoid it because we're lazy. So, because tabular is easier, not because we're lazy. So the integral of u dv, uv minus integral of v du. Yep. Yeah, but it's a little bit harder, I think. I mean, I don't want to think about it. Yeah. You could probably do it, but I don't want to get confused and lose like 15 points in one question. so like, I don't want to know. I've never tried it. I was like, eh. But I'm sure it works. So when you're doing this integral, you can let u be anything you like, but you have to be consistent. So like if you let u be the exponential, you have to continue to do that the second time. If you let u be the trig function, you have to be consistent. So I think it's easier to differentiate trig functions. So I'm going to let u be the trig function every time. So u is cosine t. And then dv is what's left over. So dv will be e to the negative st. What's missing? What do we still have to write? The dt. Yeah, that's a common mistake that people make in this class and in calculus in general. The dv always has the dt. Then we take the derivative. The derivative of cosine, is it sine or is it negative sine? Do you remember? Yeah, it's negative sine. Good. So du is negative sine t. And then don't forget the dt. It's a good review of calculus, this class. You get to review like a lot of stuff in calculus that you may not have done. And when we integrate this, we get rid of the dv and the dt, and we just divide by the negative s. So v is equal to negative 1 over s e to the negative st. So here we are. Let's pause here for a moment. Okay, so you call this piece u, you find your du, this is your dv, and then you find your v. So now you do uv minus the integral of v du. So I'm going to draw the arrow here. So uv, so I'm going to put the negative, I'm going to put this first. Okay, so it'll be negative 1 over s, and then the e to the negative st. And then the u. Get confused. So that's uv minus the integral of v du. So negative and negative is positive, and we're subtracting. So it's just going to be minus the integral. And I'm going to leave the constant in. It turns out that it's easier if you leave the constant in the first time and you pull it out the second time. How do I know that? I've just done it. So it saves you one step. So if you leave the constant in the first time, and then when you do it again, you pull it out, it'll save you one step. Just, it's a good advice. I mean, you can leave it out, but it'll make it harder. If you pull it out, it creates an extra step. So what do you do with the negative and the Say that again? With the negative. No, good question. Yeah, thanks. Good. Yeah, I'll wait. I'll pause. I love how it doesn't follow me. I can like walk off. I know. When I was making mistakes and it was looking at me, it's like, yeah, and that thing on my neck. And then I can't walk. I can't do this. You know, before I couldn't do that because it's like, oh, like it was controlling me. I feel like I'm free. All right, so we have to do it again, right? So which one should we let the u be, the trig or the exponential? The trig, yeah, the sign. If you let u be this, it goes in a loop, it doesn't work. The first time I ever taught Calc 2, I almost did that, and this girl corrected me, and she saved me. So
We do what?
if you let u be the e part, it won't work. I'm pretty sure it won't work. You have to let u be sine. I know, it's weird.
Funky.
It's super funky. So u is equal to sine t. It's a beautiful problem. And then dv will be negative, is what's left over, zoned out. Let's differentiate sine, so we get du. That's going to be cosine t dt. Integrating dv, it's going to give us negative 1 over s squared e to the negative st. I'm going to put this in parentheses. I like to put it in parentheses just to like separate the train of thought. So we found our u. dv is what's left over. We integrate, so we get that. Everything looks good. So,
I see where it says this stuff.
huh?
I see where it says.
Yeah, because if you have the s out here, you have to distribute it, right? Yes, it makes it, I know. I've learned that the hard way. I'm like, oh, this sucks. Like, let me leave it in. Just, yeah, it makes it easier when you do these, and it's just so much pain. Like, you learn to math is all about keeping it simple. Like, easy math is the best math. If you actually come up with a proof to something that's been proven and it's shorter and it's simpler, you can publish it, because that's how big of a deal it is, in some cases. Minus. So I'm going to use a bracket here. Okay, so it'll be uv. So it'll be this times this times this. So it's negative 1 over s squared e to the negative st sine t. I'm going to draw the arrow. I feel like I should draw the arrow. There we go. And then minus the integral of v du. But there's already a minus here. So it's going to become a plus. So plus the integral. And now I'm going to pull it out. So v du, so 1 over s squared.
That's going to equal I, right?
That's going to equal I. Yep. While you're quick. Yep. Yep. Yeah, that's going to be the same thing. Good. Yeah, this is exactly what we started with. That's a 2 there, I'm sorry. That's an s squared. So this is I. So I is equal to this, and it has an I. So it shows up in the same equation. Yeah?
Can you explain? So did you just, for before you did the 1 over s squared?
This?
Yeah, why did you put the plus?
Because it's uv minus v du. But there's a negative here. You see? Yeah, good question. No, it's ask. It's important to understand every step. It's worth it. It'll save you time on the weekends. So or whenever. So if you already get it in class, then you can go home and oh yeah, it's easy. Well, maybe.
Did you distribute the negative once it says negative integral? Yeah.
Not yet. It's right here. It's right here. So this is this. See it? And this minus is this minus. See it? You do? Okay, I'll wait. Take your time. Take your time. It's worth it. We got time. We're going to make it count.
Why do we want to have I?
Because we're going to solve for I. And then we'll have the answer, because we're looking for I. Have you ever seen this before? You haven't? Oh, this is life-changing. This is well, at least in math. This is amazing. This is an incredible technique. The first time you see this, it's oh. I cried the first time I saw this. No, I'm kidding. I'm kidding. It's better with numbers. It is. When you see it in Calc 2, Renee, you have numbers here. Not Renee, Anna. You have numbers here. You sit too close. So it's easier in Calc 2. In Calc 2, it's e to the 2x cosine 3x.
I mean, I've seen, integration by parts.
But not this. Yeah, this is a specific one that's I usually always put it on their test in Calc 2. Yeah.
I don't remember this one too.
I make a big deal about it. I do it in class. It's going to be on the test. Make sure you know how to do it. You're done?
Yeah, I finished the video.
Good. I was thinking she's probably done. It's good. Nerding out. No, I'm kidding. It's good. It's good. It's good. It's good. No, it's good. I'm sorry. That's really good. Did you get the right answer? Oh, that's awesome. That's really good. Okay. I'm going to keep going here, okay? So what do we have? I'm going to come back to this board here. We have I equals, so we have this, negative 1 over s, e to the negative st, cosine t, plus 1 over s squared, e to the negative st, sine t, minus 1 over s squared, I. I always think of pirates. Pirates say I. Or actually, they say R. R. You could use R, I guess, but I. So it's a really weird technique. So now we have to solve for I. Yep, so we have to add this over. And I think like Urash said, with numbers it's easier. Like in Calc 2 you have like a 3/4 here or something, so it's easier. So we're going to add this over here. So this addition, when you add these, when you do I plus 1 over s squared I, because that's what we're going to do, we're going to add this to the other side. When you do this, you can pull out an I and you get this, which is this. I feel like I'm showing too much work, but I guess no such thing. Well, maybe there is a such thing. I think this is one of those cases. It doesn't matter. It's too late. I've already committed. I'm going to keep going. So it's that. You can do it in your head, right, if you want to. But basically, you're thinking of it like this. It's s squared over s squared, s squared. So you want to think of it like this. So you get I s squared plus 1 over s squared. In Calc 2, it's easier because you have numbers, so you can just add them up. So whenever there's s's, it's way more complicated. And then we have all of this stuff again. I'm gonna write it again. You could write an arrow, but it'll make it harder. I was thinking of Mobudu, your method. In this case, I don't think your method would be a good idea, but in other cases, it's good. So yeah. Notice there's no plus c. Don't worry about it. Usually you finish it, you write plus c at the end. Although in this case, we're not done. When we do this, we still got to go back and finish the problem. Or we're finding a Laplace transform. Any questions? Oh, people start writing. I'll wait. Walk over here. What's this?
If you think about it, your S is going to look like 2.
Yeah. Yeah, check it out. No, I don't know. I'm trying to make them look like 2s. I don't know.
What's that one over there? You got an S squared and
Where? This s squared? This one? This?
the far bottom one. Far right one, I mean.
Say when? Here?
Yeah, that one.
22 or 2s? That is the question. My beta, huh? Oh, look at that.
You got it.
Yeah, it's like a face. You do a little. Huh? Yeah, oh yeah. I'm just waiting for you all to write, so I'm just waiting. People are still writing. It's a lot to write. Take your time. I know, it's a long, I know. I'm purposely pausing, let you catch up.
I mean, more than the long problem, because I feel like we've done longer than this. I don't like the long equations.
This is really intense. I know it's really bad. The DEs are longer. Because the DE will do it that's longer than this. Every test, we always get a longer and longer. The fourth test is just ridiculous. Like we'll do a question, it'll take 50 minutes for one problem.
Oh, no.
Yeah, it's really beautiful though. It's like, wow. It'll feel like you just feel different when you're done. It's like your mind is like, yeah, you'll have a take-home portion for the test. But you will. So now we have to get rid of this. So we're going to multiply by the reciprocal. So by s squared over s squared plus 1. Okay, so I'm going to go ahead and multiply by the reciprocal. So we're going to do it in our heads. So multiplying by the reciprocal here, we're going to lose one of the s's. So we have a negative s over s squared plus 1 e to the negative st cosine t. Because we're multiplying by the reciprocal, so s squared over s gives us s. Okay? And then same thing here, except here we lose both copies of s squared. So we're left with plus 1 over s squared plus 1 e to the negative st sine t. Don't worry about the plus c. We're being abusive because you don't need it, right? We can just like not write it because we're going to do the definite one. I mean, you could put it if you want to be perfect, but I won't take off points. I'll know what you're doing.
Canceling the s from the exponent?
Yes, because we're multiplying. So basically we're multiplying by the s squared over s squared plus 1. So one of them cancels here, and then both of them cancel in the second piece. Good. Take your time. I'll wait. It's pretty intense problems. I'm glad I'm doing it. I'm glad we're doing this because like Anna had never seen this. So that's good. And who else had never seen this technique on this problem? Really? You all had never? Okay, totally worth it then. This is like one of the prettiest integrals. Okay, this integral has its own Wikipedia page, I'm pretty sure. There's another way of doing it on Wikipedia, and there's a guy, Math Dr. Bob, he's really cool. He used to make YouTube videos, but he's really smart. He actually has a PhD and stuff. He had a video where he did it another way, but it's harder, so I never watched the video.
What's
So.
called applying the linearity?
I'm not sure. I don't know. Maybe. I don't know. Maybe. I don't know. I've always made it, I've called it a looper, but I made that name up. It's totally made up.
I'm just gonna start saying loop right now.
Yeah, it's just made up.
It'll catch on.
Yeah.
20 years from now.
Yeah, I'll be dead.
It'll be
Become famous post, what is it called when you become famous after you die?
post-mortem.
Posthumous? Postmortem? What is it?
Yeah, I say posthumous.
Posthumous. But I'll never become famous. Okay, so, so any questions so far? What is that, beta? All right, let's do it. Let's finish. So this is equal to, let's go back. What are we even doing? We're trying to find the Laplace of this, right? Like, what's going on? So I'm going to skip some steps here. So we're just going to integrate this, which we already did. Which one do we plug in first? The 0 or the pi?
Oh my god.
The pi. Yeah, we got to go back to the beginning. So, and we plug it in for the t. So I'm going to skip some steps here. So we're plugging in the pi. The cosine of pi is what? Do you all know? -1. But there's already a negative there. So it's going to become positive. So it's going to be s over s squared plus 1 e to the negative s pi. That just looks awesome, right? I mean, s pi, like what is that? So it just looks really cool whenever you have an s and a pi and there's an e there. I love that. It looks very like Greek. So these cancels that. Okay, and then plus, oh, what's the sign of pi? 0! Yes, this is plus. 0! It's gone. It feels so good to get to the end of this problem. It's like, yes. And I haven't messed up. It's great. Usually every semester I mess up. I make so many mistakes. Oh, we're not done yet, I guess. Then minus parentheses. And we're plugging in 0. So cosine of 0 is 1. E to the 0 is 1, so we just get negative s over s squared plus 1. And then, sine of 0 is 0. 0. So we end up with s over s squared plus 1, e to the negative s pi plus s over s squared. You can put it over the same denominator, or you can leave it like that. I'll just leave it. Oh, I'll put it over the same
Also factor out the s off the top.
You can also factor out the s on the top. I'm going to write it like this. S e to the negative pi s, just to make it look weird, plus s over s squared plus 1. I should have factored out the s. That looks prettier. Too late. You're right. Beautiful stuff. Anyone like this problem besides me a little bit? It's pretty cool, right? It's pretty cool. So really, really, really important technique. I'm really glad I did it since some of you had never seen it. Let's go ahead and talk about the formulas. So formulas. So these are the key formulas for Laplace transforms. If you take this course at another school, or if you take another course in engineering or in DE, you might have different formulas. They might give you extra formulas. This book kind of gives the bare minimum. So the first formula is a simple formula, but it's an important one. It's the Laplace transform of 1. So Laplace transform of 1 is equal to 1 over s. So super important. I cannot count how many times I've taken the test, because I take it with you because I have to get the answers. And I get to the very last question on the test, and I do the problem, and I forget this. I'm like, oh my god, what's the Laplace of 1? 1 over s. It's so easy, it's hard. So super, super key formula. The other formula, another formula, is the Laplace of t to the n. And this is equal to always. It's always whatever is here, and it's a factorial. So n factorial. And it's always 1 higher on the bottom. So n plus 1. So always 1 higher on the bottom. As an example of this, let me just give you a quick example. Say you had the Laplace transform of t squared. So we had to work this out, Laplace of t squared. This is really simple with the formula. You see n is equal to 2. So it's just going to be 2 factorial, which is 2, but I'll write 2 factorial. And then it's 1 higher on the bottom. So it would be s to the 3. Yep. And the very last step is to recognize that 2 factorial is 2 times 1, which is 2. So this is equal to 2 over s cubed. And that would be the final answer. So easy 5 points on the test. So that's it. It's really simple. It's really easy. So you become a master at this. So again, it's 2 factorial, and then it's 1 higher on the bottom every time. Every single time. Maybe I should do an example of this one up here, just so you see it. Say we have the Laplace transform. What's a fun number? 11. How weird. Okay, 11. 11. It's like 2 vertical lines. The number 11. What does it represent? Nothing. It's 11. So you can pull out the constant. So there's those vertical lines. That looks really weird. And we have the Laplace of 1. So you can pull constants out of the Laplace transform. So we have 11 times, and what was the Laplace of 1? Do you remember? 1 over s. Good, you remember? So 1 over s. So it's going to be 11 over s. And that's it. Another easy 5 points on the test, right? Knocking them out.
So what do you do that 11 again? You just got it out of...
You just pull it out. You can pull numbers out because it's linear. Remember, you can pull numbers out. Remember the alpha and the beta? I don't even remember the beta, but you can pull numbers out. Sorry. Good. That's good. By the way, this formula in the book says holds for n equals 1, 2, 3. It also holds when n is equal to 0. When n is equal to 0, you get 0 factorial, which is 1 over s. So you get 1 over s. So if you plug in 0, it's just this formula. The reason this formula is given, I think, is because of convenience. It's just convenient to have it memorized. What else? Oh, the Laplace of e to the at. This is equal to 1 over s minus a. That's it. I felt like I was going to say something else, but that's it.
Is this the stuff that you're talking about when you said it was just really easy to check in your head?
Yep. Yeah, it's pretty easy. Yeah, this is the stuff. It's like boom, 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 boom. Study though. Don't be like, oh, she said it was easy, so I'll just study 10 minutes before the test. No, I don't think so. Yeah, it's worth it. Try to get 100. So let's say we have the Laplace. What's another fun number we can use? 15? Oh, okay. 15 is a 5. T. 15t. So using this formula, it would be 1 over, and then it would just be s minus 15. And that's it. Because your a is 15. If it was like a negative 15, it'd be 1 over s plus 15. Yeah, it's the constant. Yeah. Yeah. So if it's like e to the 4t, it's 1 over s minus 4. Any questions so far on these questions? It's important. You'll get really good at this. The reason you have that worksheet is because the homework is super easy. So we'll do most of the homework and we'll do some of the worksheet today as well too.
When it comes to showing work for the exam.
I don't care.
Okay.
It's you. It's on you. It's up to you. For these, yeah, it's up to you. Yeah, because that's really easy, right? Most people skip a lot of steps. I'm okay with it.
This is what the problems are going to be like?
Some of them you might have a couple.
Short,
A little bit harder maybe, but yeah. These are just the formulas, so I'm doing the easiest ones.
I know,
But yeah, it's good.
Just substitution pretty much. That's it.
Yeah, totally, right? It's awesome. All right, how about these? So we have Laplace of cosine kt. And then we have Laplace of sine kt. So I'm going to show you how to memorize these. I know you say, well, you have a formula sheet. You don't have to memorize them. But it's totally worth memorizing them. You want to have them memorized. They do get harder. Later in the next sections, we'll be doing harder ones. So here's how I memorize these. So on the bottom, it's s squared plus k squared. Same thing here. It's s squared plus k squared on the bottom. The top is what's different. So the way I memorize it is I just remember that cosine has the s. Right? Cosine, has the s. Cosine has the s.
You know what's kind of cool about that is co is a prefix meaning with, and cos with s Did it, you know?
That's exactly why I said that. No, I'm kidding. I didn't know that. No. Co with S. Yeah, with the S. So cosine has the S, and then sine has the K. Sine has the K. That's the boring. Just memorize cosine has the S, and you got this all day long.
The K's actually there, it's just that it's silent.
Is it? Yeah. It's sine. Yeah. So here's an example. Say you had the Laplace of cosine of 2t.
Tutti.
2t.
Tutti frutti.
Tutti frutti. I don't know what that means. But the Laplace of...
It's a flavor.
Oh, it's a flavor. Of cosine 2t. So, cosine has the s. And then it would be s squared plus 2 squared. So s squared plus 4. That's it.
It doesn't make sense because like cosine starts with the K sound and then
Don't say that. No. Someone in my other class is like, cosine has the K. I'm like, no. So you'll mess up. I get confused. No, oh my God. So cosine has the S. There we go. So here's another example. Let's do an example with sine. There's some homework questions that are this easy. Sine. You can type it into Wolfram too. Type in Wolfram, like Laplace sine 3t. It gives you the answers. That's how I got all the answers to the worksheet. I just typed them all into Wolfram. I didn't do any of them. Didn't want to mess up. Okay.
2 plus 3
3 over
s squared plus 9.
plus 9. That's it. You got this. Beautiful. It's awesome. I love this stuff. And you do this a lot in other classes. And in those other classes, you'll probably have a formula sheet. But honestly, you'll have them memorized. Just remember, cosine has the S. There's 2 more. The last 2 are the hyperbolic ones. So we have cosinch of kt and sinh of kt. So cosinch and sinh of kt. I bet the homework is really easy. Okay. So cosinch has the S. I almost messed up. I almost said cosinch has the K, but no. Cosinch has the S. And then it's hyperbolic, so it has a minus on the bottom. The hyperbolic ones have minuses. Think of hyperbolas. And then sinh has the, what do you think?
They just stick, pretty much. They're the same.
Yep. Yep.
Step a little bit.
Oh, I know. Are you sick or no? I went to my office. I had like 4 emails about people who were sick and they're not here, and like
Ooh, let's hope it's not.
people in my online class are like, "Do we have to come to campus and take the test because of what's going on? I have no immune system." I'm like, "Oh my God!" I just replied, "Yes, the college is still closed as far as I know." So that's all I said. So
Wait, they're taking it online.
they go to the testing center to take the
Why would they have
test.
to take it on the campus?
It has to be proctored.
Always.
I know.
Is
Yes.
it what class is that?
College algebra.
It has to be proctored?
Yeah, the math department has a rule. At least 70% of your grades has to be proctored. Yeah.
That's annoying.
Yeah. Yeah, no comment. Being recorded. Okay, so let's do some homework. No, it's whatever. No opinion. Number 9. Let's do it. Number 9. Let's do as much homework as we can do. Laplace of, I already forgot what it was. 5t cubed. 5t cubed. By the way, everyone knows what factorials are, right? Like 3 factorial is 3 times 2 times 1. 4 factorial is 4 times 3 times 2 times 1. Okay. Yeah, it's 24. Yeah. So the 5 here, you can pull it out. So it'd be 5 Laplace of t cubed. Yeah, I like to show all the work. Anna had a good question. She said, "Do you have to?" This Anna, there's 2 Annas. How did you? I know. I don't know. Anna, or it doesn't matter. She's asking about showing work. You don't have to show work. Show what you can. So this is 5, and then 3 factorial over s to the what? What would go here in this case? No. 4. Yeah, because 1 higher. It's always 1 higher on the bottom. So it's 3 factorial, and then it's always 1 higher on the bottom here.
So the top one is the one that's like that.
Yeah, the top one, it just becomes a factorial, and it's 1 higher on the bottom. That's how I memorize the formula, because it looks kind of cryptic. So the top one becomes a factorial, and it's always 1 higher on the bottom. Okay, 3 factorial is 3 times 2 times 1, which is 6. So this is 5 times 6, so this is 30 over s to the 4th. You all know what 3 factorial is, right? Yeah, so you know what 5 factorial is? 5, 4, 3, 2, 1. So if you have 1, 2, 3, 4, 5 people at Walmart, and they're trying to buy licorice, and there's one cashier, and it's 2 a.m., there's 5 ways to put the first person in line, 4 ways to pick the second person, 3 ways to pick the next person, 2 ways to pick the next person. It's 120, and there's 120 ways to line up 5 people. So 5 factorial is the number of ways to line up 5 people. 3 factorial is the number of ways. 3 factorial is the number of ways to line up 3 people, etc. So, okay, number 10. Number 10. Let's do it. Number 10. Laplace. Yeah, it's really easy. 5t. We'll do the worksheet soon. 5t minus 7. I'm going to go fast. I'm going to try to do as many problems as we can do. So stop me if you have questions. So I'm going to try to do like tons of examples so we can like finish this section. I mean, we can do more next time, but it'd be really cool if we finish a full section like Rafael suggested at the beginning of class. Like knock a section out and we have 2 full days. You can skip steps. I'm not going to. I really like to show the work on these. It's just personal preference. So it's 5 Laplace of t minus, and then 7 Laplace of, what would go here? 1. Yeah, again, the reason I show steps is because when we get to the shifting theorems, which is later, the shifts, those are really powerful, it's really important to show the work. Like if you mess up, it hurts. Like, I mean, especially if this is worth 8 points, you don't want to mess up. There's a 1 here, so this is 5. So it's 1 factorial over s, what would go here? 2, very good, it's 1 higher, minus 7. Oh, what's the Laplace of 1? 1 over s, yeah, I always forget that, it's sad. So you just get 5 over s squared minus 7 over s. And that would be the final answer. So 5 over s squared minus 7 over s. So again, it's 1 factorial, 1 higher on the bottom. Laplace of 1 is 1 over s. Piece of cake. That's number 10. Number 10. Let's keep going. Let's keep going. That was number 10. Number 11 is kind of easy. 12, I kind of want to skip it. Let's do 17. I'm just skipping around. Why? I don't know. I just felt like doing that. Which one did I say? 17? Yeah, 17. 17. It's the Laplace of, I already forgot what it was. Anyone have it up? Uh-huh. Perfect. This is definitely something you would see on a test. Okay, so this is like super important. This is considered like total every semester, no matter what. It's always there. So this one requires an identity. So I'm going to refresh your memory on some trig identities that you should know. So there's 3 of them that you want to know for the test. The first one is the one we're going to use here. So sine 2x is 2 sine x cosine x. The worksheet has additional problems regarding these. So this is an important trig identity that you'll want to know. The other ones you'll want to know are cosine squared x and sine squared x. And these are the ones that have the 2 on the bottom. This one has the plus, and it's all over 2. And this one has the minus, and it's all over 2. So you'll want to memorize all 3 of these for the test. Just remember, cosine has the plus, sine has the minus, and this one's pretty easy. You learn these in trig, but not really. Like, you don't really learn them this way in trig. They mainly come up in Calc 2, chapter 8. I think this is section 8.4. I forgot what section it was, but it's one of the sections in Calc 2. The trigonometric integrals, like when you integrate like sine to the 4th, stuff like that. So in a problem like this, if you want to show some extra steps, it's up to you. But you can take this trig identity and solve it for sine x, cosine x. I'll do it over here. Look, sine x, cosine x is 1/2 sine 2x. I'll show all the work. You see, so this is the formula you want to use for this problem. And if you put an x equal to 4t here, if you replace x with 4t, replace x with 4t, going kind of fast, sorry, because I have like 14 minutes. This is 1/2 sine and it'd be 2 times 4t, which is just 1/2 sine of 8t. Everyone see what we did? So it becomes 8t. Becomes 8t. So you just replace x. So this is really the Laplace of 1/2 sine 8t. So this is going to become, you can pull the 1/2 out, Laplace sine 8t. Okay. So you can show as much or as little as work as you want. It's up to you. Imagine doing this with the definition. You would get e to the negative st sine 4t cosine 4t. Game over, right? You'd have to use that. You'd want to use the identity. It'd be really ridiculous. Any questions on that? Because I went through that kind of fast. Okay. So it's 1/2. Does sine have the s or does it have the k? It has the k. Yeah. So it's 8 over and then s squared plus 64. Yeah, 8 squared is 64.
Okay, it's constant.
K is the constant. And then these cancel. So you just get 4 over s squared plus 64. And that's it. This will be considered a harder question.
Can you do question 16?
Absolutely. Yeah, that's a beautiful question. We should totally do it. Yes, thank you. Very good. We'll do 16. 16 is also on the worksheet. There's additional ones like 16 on the worksheet for practice. Huh? Oh, okay, yeah, go for it. Yeah. Hey, hi, Mom. I'm kidding. No. Go ahead. I'm out of it. You got it? That's okay. It's all right. Huh? That's so stupid. I'm not. I hate pictures. I have no pictures of myself. I don't like pictures. Yeah, but there's no, like in where I live in my house, there's no pictures of me in the house.
Do thumbnails not count as pictures?
No, there's no, I have no personal pictures. When I was a kid, you know those pictures you take in school, like the school pictures? I didn't do them. Yeah, everyone did them except me because I thought they were rip-offs. I never did them, so I told my mom not to pay for them, and then I don't have any pictures of myself. Regret? No, I don't know. Doesn't matter. But all right, so got it? I was that kid who was never in the school pictures. Let's do 16. You got it, Luigi? All right, 16. 16. 16. So let's do, what is it? Like this?
Yeah.
Beautiful. Okay, so there are 3 formulas. 2 formulas you should know for the test. 2 more formulas. So the hyperbolic cosine of t is equal to the average of e to the t and e to the negative t. So you add them up and divide by 2. So that's an important formula. I don't know if you should know it, but there's another way of doing this problem, but it requires some skill that we haven't, some things we haven't done. But one way is to do it with these. So that's the hyperbolic cosine of t. And then the sine, sinh, do you know what that one has?
Are those more identities we should know?
Yeah.
Well, those are hyperbolic.
Should have been the formation.
No, that one I would feel bad. I don't feel bad about giving you the Laplace ones, but these are, I don't know. I don't know. These are really important. These is like.
I feel like at this point, if you haven't memorized those, you're making yourself do so much more work every time to memorize them.
Yeah.
They always come up.
Yeah.
Every term.
Now, even I know them. I mean, what of them? Like, I know, but still, like, I'm like anti-memorization. Like, I'm one of those people that like it took me years to learn what the sine of pi over 3 was. Okay, so this is it's the square root of 3 over 2, but this is Laplace e to the t. Oh, I almost messed up. Okay, I got to focus. Sinh has the minus.
Yes.
Right. Okay. Oh, geez. It's getting late. All right. So.
Yeah, blame it on the time.
Yeah, totally. Yeah. Oh, wow. All right. So now we distribute. Okay. So and we can pull out the 1/2. So this is
E to the 2t.
e to the 2t.
Minus e to the 2t. So you got 0? What?
Yeah, and this is going to be minus 1/2. I feel bad. I'm going to show the work. I'll show the work. Because I feel like I skipped some major steps here. So basically, here's what happened. This is a 1/2. This is the Laplace. And then here we have e to the t minus e to the negative t.
Yeah.
So now e to the t times e to the t.
I didn't see the negative t. So I thought it was just the t.
And then when you distribute here, you get 1. You see, they cancel.
So was that an error?
No, what error?
You added the,
No, I erased it and wrote it again. No, it was just, no. Just walk away. Too bad we can't like go till 11, but I know it's bad. I know, just go all night. Like, I heard there's some schools that have classes like at 1 a.m.
Full SAM?
Yeah, I was about to say it. Yep. So this is 1/2. So this is 1 over, do you remember s minus 2, right? Because it's s minus a, the e1, right? It's s minus the constant, okay? And then minus 1/2. And then what's the Laplace of 1? 1 over s. And that's it. That's it. That's it. It's pretty good. That's a really good one to do. Let's do something from the worksheet. Let's maybe do let's do 2h from the worksheet. Any questions on this one? Questions? Let's do 2h from the worksheet. So this is number 2h. And this is from the worksheet. There's some other homework ones that are worth doing, but like, I'd rather do this. I feel like this is more productive. So we have the Laplace of cosine squared of 4t. So cosine squared of 4t. So basically we're using this formula, this one here, this identity. So this is going to be the Laplace of 1 plus cosine, well, it's 4t times that. So what do you think it's going to be? 8t. Good. 8t over 2. Also something that's usually always on the test every single time, no matter what, like every semester. If you look at the old test, like I said, if you can do that, you're ready for the test. Like it's really long. Usually you have one of, everything's on there usually. You have quite a few of these. This really helps your grade. People usually people usually do really well. Usually, third test, you can't withdraw anymore, it's too late, so people try harder, right? So like, this is it, you're in it, like, you're gonna get a grade. It's like, nah, it's like do or die. People do well. I'm gonna show an extra step here. This is 1/2 plus 1/2. I never do this, but I figured, what, let me just be different. I don't know why I did that. And then so it's just this over this plus this over this. And then you can break it up. You can skip steps. This is 1/2 Laplace of 1 plus 1/2 Laplace of cosine 8t.
Would it be improper to just pull the 1/2 out and keep it as the Laplace of 1 plus cosine of 8t?
That's fine.
You could just keep it.
Yeah, and then just do each one individually? Sure. So you would get 1 over s plus, yeah. That's fine. Yeah. Usually you want to break it up though, because we're going to be using this to solve DEs. So usually you want to expand it out. It makes it easier to do the DEs. So this is going to be 1/2 times 1 over s plus 1/2. We still have time. We still have 5 minutes. Yeah. So come on, what's going on? We got time. That's just here no, come on. Does it have the s or does it have the k? It has the s. Cosine has the s. Good. So it's s over s squared plus 64. Oh my God, look at that. We're done. That's it. That's the answer. We should do another one. We got time. We got time. We got time. We got time. It's worth it. It's good. Which one? 12 from the homework? That's the one that's the one I didn't want to do. You know what that means? That means we should do it. Let's do it.
Because it will be on the test.
It's gonna be too. It is. Yeah, let's do it. It'll probably be so let's do it. So I didn't want to do this one because I was like, it's late, but Let's do it.
If you wouldn't have done it,
I would have had to do it. I would have had to do it in 7.2 because it comes up there again. So yeah, I was thinking like, yeah, I was like, I don't want to do it tonight because it's too much. But you know what? It's too late.
This is number 2 from the worksheet.
Yeah, and this is number 12 from the homework.
Okay.
So Laplace of t plus 1 cubed. Now on the test it might be harder. It might be like t plus 3 to the 4th, you know, whatever. It varies, right? There's other ones, and it does get harder in the future sections a little bit. So I have this memorized. I know what this is just because I know. Let's derail for a moment and completely explain it, because this is something that you should know. It will help you in your life, in your math life. If you have this triangle, if I put a 1 here and I put 1s on the sides, this is called Pascal's triangle. And then 1 plus 1 is 2, and I put 1s here and a 1 here. 1 plus 2 is 3. 2 plus 1 is 3, 1s on the side. This is called Pascal's triangle. You can keep going, 1, 4, 6, 4, 1, etc. So I'll do it again, look from scratch. Check it out. So 1, 1, 1. 1 plus 1 is 2, 1, 1. 1 plus 2 is 3, 2 plus 1 is 3, 1, 1. 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, 1, 1. This is called row 0. This is row 1. This is row 2. This is row 3. This is row 4. 4. Nice try. No, I know I'm going really fast. I almost messed up. I was adding like 3 plus 1 is 4. I'm like, is it? This is cubed. This is cubed. So we want row 3. Check this out. So how do you do it? You do 1 times x cubed y to the 0 plus. I'll show you. So look, 3. Then you count down. You start at 3. So this is x plus y cubed. So you start at 3. So it's 3, 0, then 3, and then you count down. So it'd be x squared, and this one counts up. So y to the 0. Then you go to the next coefficient, 3.
Is it not y to the 1?
That's what I was
Yeah, so how do you count that's a point?
That's 3 points.
15 points here.
Dang, man.
Who was that? That was
Sorry.
Emily. No, it's okay. It's all right. Okay, fine. All right. It's fine. It's fine. It's fine. It's fine. It's fine. It's fine. All right. Can I finish it though? Because class is over in like a minute. Can I finish it?
Yes, go.
All right. So let me do it again.
No,
Just really quick. X plus y cubed.
yeah, go faster.
No. It's 1 x cubed y to the 0 plus 3 x squared y to the 1. 1 plus 3. Then what do you think it's going to be? X to the
That's the 1.
1. And then y to the 2. It goes up. This is the part where people mess up. The 2 becomes a 1 and a 1 becomes a 2. And the last one would be 1 x to the 0 y cubed. So it becomes x cubed plus 3x squared y. I have it memorized just from doing it. But you should be able to use it for anything. You can do 4, you can do 5. These are called binomial coefficients. I could talk about it for 10 minutes, but let's not. Where?
3x y squared.
Oh, man. All right, okay. That's just you, though. That's.
Yes.
All right. So in this example here, this is the Laplace. Wait, class is over though. It's past 8:45. Does it count? Does it count?
His
My
doesn't,
clock
the other
says
one did.
8:45.
Yeah.
Kept this, yeah.
Technically, it is
Oh, wait, my phone.
8:40.
All right. Just keep going. All right, so this one is going to be t cubed. So bad. T cubed. Yeah, 1 to the 0, so I won't write it. So just t cubed plus, and then 3t squared, 1 to the 1, so you don't need it. Right, because it's 1 to the 1. Plus 3t to the 1, and then the 1 goes away, plus 1. Right, so, yeah. Yeah. So then you just do each one. So, I'm so nervous. Laplace of t cubed, this is horrible, t cubed. I shouldn't have done this, we just called it quits. 3 Laplace t squared plus 3 Laplace of t plus Laplace of 1. We got this. Yeah, it's easy. Not going to go faster though. Okay, so this is equal to 3 factorial over s to the what? 4. Yeah, very good. S to the 4 plus 3 times 2 factorial over s cubed. Yeah, 3 plus 3 times 1 factorial over s squared plus 1 over s, I think. Yeah?
Yes.
And then, so, well, what's 3 factorial? 6, yeah. This is 6 over s to the 4th. This is 3 times 2, so it's also 6 over s cubed. And then 3 over s squared plus 1 over s. And that's it. That's it. Any questions? So next time we will, unfortunately we don't have any more time, but next time, no, I'm ready to go now. I'm over my mistake. I can keep going and not mess up, but next time we will, we'll do more stuff. We'll do more Laplaces. So that's it.